All right, so we've just finished graphing circles and going over their equations. Now we're going to look at the next conic section, which is ellipses, or just an ellipse. So an ellipse is a set of points such that the sum of the distances, so that's just what's going on over here, the sum of the distances from any point on the ellipse to the two fixed point remains constant. These fixed points are called foci. So when we talk about foci, that's what we're talking about. So that's a big term you'll need to know about an ellipse. And then our distances between those 2 points, those remain constant, which it pretty much says that there, but we'll just go ahead and write that again. So D1 plus D2 remains constant for all points on the ellipse, which that's just kind of some your information type stuff. We're not going to really, you'll see, we'll be able to calculate the foci and the focus, but we're not going to be concerned too much about it other than the calculations. All right, so there's more parts to this that we need to go over. So the major axis is the longer axis of symmetry. So you need to make sure to write all of this down. So the longer axis of symmetry is the minor or the major axis. The shorter axis of symmetry is the minor axis. And then the center is the point at which the major axis and the minor axis intersect. And then here's how our vertices will work. So our vertices are going to be the endpoints. So we'll have vertices and co-vertices. The vertices will be the endpoints of our major axis or longer axis of symmetry. So the endpoints of the major axis, which we'll look back over all this in a second. The co-vertices will just be the opposite. They'll be the endpoints of the minor axis or the shorter axis of symmetry. So those are all the parts we need to know. Now we're going to look at two types. So we'll have a horizontal ellipse. And when we have a horizontal ellipse, that just means this horizontal axis of symmetry, or axis of symmetry, that's the horizontal line here. It's longer, so that is our major axis there. Now we'll go through and label some of these, so be sure to write these down when we get to that. But next we've got our vertical ellipse, and that's just saying that our major axis is this vertical line here. So our axis of symmetry there, it's longer vertically, so that's our major axis. So that means that when we dive into labeling each of these, when we're looking at the horizontal ellipse, since this line of symmetry here is longer, that's our major axis, that means that these 2 points here and here, those points are the vertices. So that's a vertex, and that's a vertex. And then when we look at our co-vertices, they're going to be the endpoints of the smaller axis of symmetry, which in our horizontal ellipse, it's going to be our vertical line. So this endpoint here and this endpoint here will be our co-vertices, or co-vertex, however you want to say it. That's a co-vertex, that's a co-vertex. All right, and then of course here is the center of our ellipse. I think we're pretty good on that. But you'll notice we have one more thing going on here. We have these 2 points here. Those are the focus, or the foci. So that's the focus. Now when we look at our vertical ellipse, it's the same, everything's labeled pretty much the same terminology, except some things flip. Now, our longer axis of symmetry is right here, down the middle vertically of this ellipse, and those endpoints are the endpoints of our major axis, so those are our vertex points. So that's a vertex, and this is a vertex. And then these 2 endpoints here are endpoints of the smaller axis of symmetry or the minor axis. So those are going to be co-vertex or co-vertices. So that's a co-vertex, and then this one's a co-vertex. All right, and then the last thing again, now you'll notice that our focus is changed. It's not on our horizontal line, now it's on our vertical line, because your focus is always going to be on the major axis. So our focus here is on the major axis, which is the vertical line of symmetry. So this is the focus, or each point is the focus, the points together are the foci. So that's a big thing to remember, that your focus is on major axis. So our focus is going to be on our major axis, and you'll see we'll get to that in a second. All right. So now we need to label a few things, or just denote them a certain way. Then we'll get to some actual formulas. So the vertices, we call those A, and we say that they're plus or minus A units away from the center. So that means if our vertice was at, I don't know, it was 2 units away from the center of our circle, then our vertices would be plus or minus 2. And then the co-vertices, we call that B, and the same thing applies. Our co-vertices are plus or minus B units away from the center. The length of the major axis is going to be 2A. The length of the minor axis is going to be 2B. So it just means whatever A or B is, the major axis is double, and the if A were 2, it were 2 units away from the center, then we would say that our length of our major axis would just be 4, because 2 times 2 is 4. The foci is going to be plus or minus C units away from the center. And remember, the foci will always be on the major axis. Or another way you could say this is, you could say that, well, no, that's probably the best way to say it. So it's going to be on the major axis. That way we don't confuse anything. All right, then the formula to find C is going to be very similar to the Pythagorean theorem, except it is C squared is equal to A squared minus B squared. So it's not plus, it's minus. So that is not Pythagorean theorem. So not Pythagorean, I don't even know how to spell it. Pythagorean theorem. You don't really need to know that. That's just a note for you. Don't get that confused. All right, so that's what our vertices, will label those as. That's our co-vertices, length of axis, our major axis, length of minor axis, our foci, and then our formula to find C. So now let's look at the standard form of these ellipses. So when our center is at 0, 0, our standard form will look like this for a horizontal ellipse. X squared over A squared plus y squared over b squared. And that will all be equal to 1. And then our vertical ellipse will be slightly different. It will be x squared over b squared equal to y squared over a squared. Not equal to, I don't know what I'm talking about. It will be plus. And all of that will still be equal to 1. So the only thing that changes here is our B in each, our B and A in each formula, and that is depending on whether you have a horizontal major axis or a vertical major axis. So the first one here is a horizontal ellipse. The second one's a vertical ellipse, which we'll get into some of that. A lot of the times you don't have to really worry about rewriting it that way, but you'll have to make sure you know those. So then we're going to look at standard form. when the center is HK. So when the center is HK, that's very similar to how we did circles. So it's going to look very similar except a little twist. So now, instead of it just being x squared on the top, it will be x minus h, all of that squared over a squared plus y minus k squared over b squared equal to 1. And that's for a horizontal ellipse. So if you have a horizontal ellipse, a squared is going to be your bigger number. That's going to be your major axis. And then same thing for a vertical axis, except b squared and a squared will flip. So it would look like this: x minus h squared over a squared plus, or I just said we're flipping those, b squared plus y minus k squared over a squared. So that is all your general information that you need to know for this. Now, I'm going to probably split these up into 2 separate videos. So this is just the general information you need to know for this ellipse section. Next, we'll look at graphing, but I'm going to break that up into a separate video because it may be a tad bit longer than I want it to be.